Okay? All right, now, as you can imagine, all of these bars, if you start really making these bars really thin and tiny, they really do start to look like a bell curve, right? But they are discrete. They're full bars. They're not like, it's not like a weight or a length. It is specific things. So we want to include both of these bars. Now, normally, the line would come right in the middle here. We're going between here and here. But that's not going to do enough. I want to include the whole bar. So I need to add some here and here to get it. So I'm going to go a little bit below 270 on this one to 269 and a half. Because see, it's like the line that's like halfway between 269 and 270. And then how about this one? This one I'm going to go above it, yeah. So there isn't a solid, fast rule about, oh, you always go below or you always go above. It depends on the problem. Okay, so this one says at least 158. So let's make, I don't know, this one 158. What does at least mean? That or more. Is 158 included? Yeah. Okay, so we want it to be from here over. So it looks like I have to go a little bit below. So it would be x is what? Greater than or equal to 157 and a half. And if I wanted to write this one the correct way, I would have written 269.5. Just with less than or equal signs in there. How about this one? Less than 63. Let's pretend that, I don't know, this bar right here is 63. What should I write for that one? Everything to the left. Should I include 63? So should I write 63.5 or 62.5? So it needs to be less than 62.5. Okay. So that's just understanding what a correction for continuity is. And now what we're going to do is we're going to approximate, use a normal to approximate a binomial. Now, I set up this. I don't think I've done this with you before, have I? Do a lot of this now because we're going to have complicated processes. So on one side, I'm going to have directions, and on the other side, I'm going to have like, hey, remember to do this, remember to do that, remember to do this. Okay. All right, so the first step is verify you can use a normal distribution. What do you have to check to make sure that's true? That n times p is greater than 5 and n times q is greater than 5.
Or equal to.
Or equal to. You also have to make sure it's binomial. What does a binomial distribution have to have?
Specific number of trials.
Yes, so we have to know n. You have to know p, you have to know q. Yeah, that's it. And the p has to remain the same for everything. Third step is to find the mean and standard deviation. I don't suppose you happen to remember the formula for binomial mean or standard deviation. Anybody off the top of their head?
Wait.
it's, so standard deviation is equal to NCX times,
No.
no, that's a different one, NCX times.
You're thinking of the
PX.
binomial formula. We're talking about just the two little formulas that are for mean and standard deviation. Do you remember on that last test when I was like, don't do a huge thing in your calculator, there's just two little formulas that does this for you?
Oh, it's n times p,
Uh-huh.
n times p times.
Close. Square root of n times p times q. That one was the variance. Get it right, Georgia. Come on. Square root. Ridiculous. All right. Next is to figure out the correction for continuity. Again, that's adding or subtracting 0.5. Depending on the situation.
That isn't always 0.5.
Yes. Because those halfway between that one and the next one. Next is to find the z-score. Hey Justin, what's the formula for a z-score? Sing it.
X minus over sigma. Dude, that was so good too.
It was so
That was
good.
my best one I've done so far. Now I'm gonna get that again.
You're gonna forget your line on stage and you're just gonna x minus mu over sigma. And I'll be like, what? And Wilmus would be like, what Greek letters is he saying? And I'll be like, it's a math thing. All right, find the probability. What do you think of this like step format I'm using here? It's pretty cool, pretty neat. That's on A16 or A17 or your handout or whatever. Do you actually like this format?
Yeah.
Okay. All right. What percent of people in the United States admit that they snoop in other people's medicine cabinets?
Zero. Zero.
Crazy.
No, it's higher than zero.
What do they got?
It's a
Is it like
22.
Like, we're going like a.
Advil or an ibuprofen family?
45% of people
No.
say they snoop in other people's medicine cabinets.
What are you doing in. Why? What are you in there?
Well, I'm glad you guys think this is rude.
This has to be like something.
You think there's a sampling error? They only ask jerks. They're like, hey, real quick, are you a jerk? No? Never mind. I don't want to ask you my question. And still only 45% of jerks said yes. All right. You randomly select 200 people in the United States. Ask each if they snoop. What's the probability that at least 70 will say yes? Okay, first of all, do we understand why this is binomial? N equals 200. 200 trials. What's the probability of success? 45%. Probability of failure? 55. So, N times P, bigger than 5? Is 45% of 200 bigger than 5?
Yes.
Mm-hmm. Yes, it is. I'm just going to write NP, yeah. The reason why we're doing this is because on the AP test, this is like an exact great question that they would ask you for like a free response. And they're checking things like this. They want to see that you actually check to see if you could do it. So just writing something like that is enough, where they're like, oh, yep, they looked. All right, probability that at least 70 will say yes. All right, we have to find the mean and the standard deviation. So the mean is 45% of 200. Can you do it in your head?
Yeah,
How much?
90.
Uh-huh.
You just double it.
You just double it?
Oh, in this case at least. 'Cause I'm just 200.
And the square root of 200.